Hi, welcome to another mini lecture. Today's topic is sine, cosine, and tangent ratios, numbers for side length. So let me just briefly explain what the topic is about here, and it will be a quick and short lecture. So the issue is that we have a right triangle and let's say label these corners and angles as say A, B, and C. This is a right triangle, so here is our 90-degree angle. Typically this is labeled a little a, and this is little b, and this is a little c. If I'm looking at angle A, then sine of that angle A is the ratio of its opposite to the hypotenuse. Cosine of the angle A is the ratio of its adjacent divided by hypotenuse. Tangent of the angle A is equal to ratio of its opposite divided by its adjacent. So these are always opposite and hypotenuse for the sine, adjacent and hypotenuse for cosine, and opposite over adjacent for tangent. And same with other three trig functions. They're just reciprocals of these. So here our challenge is to repeat this thing often enough so that it becomes second nature, and I would suggest that the only way to do that is to write and rewrite as many times as you can. I understand that it's a rather tiring thing to do right over and over again, but you kind of build a type of muscle memory, and this gets ingrained in your mind. If you just rely on typing on your keyboard, it's very unlikely that this stuff is going to stay in your mind. So every time you see this thing, write as much as possible. So it's asking sine of angle L. So with respect to L, if this is the angle L for me, then this is the opposite of L, and this is the adjacent of L, and this is the hypotenuse in general anyway. So sine of L is the ratio of its opposite over adjacent, and tangent is the ratio of its opposite. So when you come across this question of what is tangent of L, actually literally write this thing out. Write that it is equal to opposite over adjacent. Just go look it up again. Opposite is 5, adjacent is 12, and cosine of L is the ratio of, so we repeat, cosine of L is the ratio of adjacent of the angle L to the hypotenuse of, so let's write it again. Let me listen to my own advice. Sine of L, opposite over hypotenuse as well. So cosine becomes a ratio of 12 over 13. Now you see these pictures drawn in this way. It's perhaps a bit misleading. The idea of this type of a definition is that we don't have any particular direction in the plane. There is no preferred direction. There is no such thing as x-axis or y-axis or anything. It's just a triangle. Okay, so it's just a triangle, and these ratios apply. 5, 12, 13 is one of those magical triplets. 5 squared plus 12 squared is equal to 13 squared. So one of those rare instances where all three sides are whole numbers. Here's another example, 9, 40, and 41. That's another magical triplet. And tangent of, again, our angle is just x, so tangent is the ratio of its opposite over its adjacent. Sine is ratio its opposite over hypotenuse. Cosine is the, so let's write this was opposite over adjacent. This one was you essentially want to stop this recording and answer and then come back and double check. Sine is going to be opposite over hypotenuse, and this one is going to be adjacent over hypotenuse again, so that's going to be 40 over 41. And again we have this magic going on. 40 squared plus 9 squared is equal to 41 squared. So if you are interested in where does this mysterious triplet come from, where are the rest of them, how to get them and such, you are a good candidate for mathematics, and that makes for interesting reading or interesting project. At any rate, here's another example. 724.25, and then this time the angle of interest is here. So what's cosine? Cosine will be, of course, adjacent of y over hypotenuse. Tangent will be opposite of y over adjacent, and sine will be opposite of y to hypotenuse, and so on. So again, we have this definition for sine, cosine, and tangent. Ratios, we have 3 sides. We can make 6 ratios out of them. These 3 are the primary ones that show up on your calculator, and the reciprocals of these are the secondary ones that you obtain by taking, well, the reciprocal. Okay, so that's enough for this topic. Until next time, good luck and God bless.